All right, welcome back. So today we are discussing implicit functions, differentiation of implicit functions. So before we look at what an implicit function is, let us look at what an explicit function looks like. So when a function has y variable explicitly defined, okay, or y is the subject of the formula, this is known as explicit function, okay, where the variables are explicitly defined. Okay, the y variables are on one side of the equation and the x variables are on the other side. For example, if you have a function y is equal to x squared plus 3x plus 5, this is an explicit function, and to find y prime, it is just very easy. To find dy dx is very easy. You just differentiate this variable, you get 2x plus, differentiate that, 3, differentiate the constant, you get a 0. But for implicit functions, for example, implicit functions, they are in this form. We have, let me give an example of an implicit function, x squared plus y squared plus 2xy is equal to 0. When we look at this function, y is not a subject of the formula and x is not a subject. Things are not explicitly defined. So this is classified to be an implicit function. Y is not a subject. So how do you differentiate functions like this one? So what you do is, the simplest way of thinking about this is that you differentiate each variable, okay? Differentiate each variable, and whenever you differentiate the y variable, you multiply it by the y dx. So let's differentiate this variable here. You're going to get 2x plus, differentiate this variable there, we're going to get 2y. So whenever we differentiate the y variable, we write dy multiplied by dy dx plus. Here we have got two variables, x and y, so product rule. So differentiate first this variable here, we're going to get 2y remains plus, differentiate the second variable y, we're going to have 2x. Since when you differentiate this, you get a 1, you write dy over dx equal to 0. And then you make dy dx the subject to the formula. So collecting the like terms of dy dx, we're going to have 2y dy over dx plus 2x of dy over dx. This is equal to negative 2x minus 2y. This 2x and then this 2y. Then you factorize your dy dx there. You factorize your dy dx. Factorize your dy dx. Here remain with 2y plus there 2x being equal to minus, I can just factorize my negative 1 here plus 2y. Then divide by this, okay? You are going to have dy over dx will be equal to minus 2x plus 2y over 2y plus 2x. Okay, 2y plus 2x. And then your dy dx is going to be equal to, this is going to be a negative 2x plus 2y over, this is 2x plus 2y. So this is going to be a 1. So you have 2y dx is going to be negative 1. This is your dy dx of an implicit function. Let me give another example. Implicit function. The example I can give is, we have 2y squared minus 5 x to the power 4 minus 2 plus 7y power 3 is equal to 0. So find dy dx. So find dy dx. To find dy dx, let's differentiate the first variable here, y. You're going to have the first variable y, you're going to have 2 times 2y dy dx plus minus the power times the coefficient, you get a 20, reduce the power by 1, you get 3, derivative of a constant is 0, then 3 times plus 21y to the power 2 dy dx. Okay, so you get 4y dy dx plus 21y squared dy dx being equal to 20x to the power 3. Then factorize the dy dx from here. Factorize dy dx. So your dy over dx will be equal to 4y plus 21y squared will be equal to 20x to the power 3. Divide by 4y plus 21y squared. So you're going to have dy over dx being equal to 20x to the power 3 over 4y plus 21y squared. That is how you find dy dx.